Okay, stats. This is part 2 of the John Baylor analysis of the test data that we had for those 12 students. We already did the test yesterday that said that composite scores after John Baylor were significantly higher. So John Baylor did have a effect on scores and helped to increase them. So what we're going to do on the back side here is we're going to test each one of these categories. So composite scores, we know overall it raised categories, but was one of the categories not quite as effective as another category. So, I've heard kids say, "Oh yeah, the John Baylor really helped me in math," but like it did nothing for science because you can't really prepare for the science test. They say because it's all graphs and stuff. So let's see if one of these was less effective than the other one. Okay. So what I'm going to do is we're going to set this up exactly the same as we did before. The claim is going to be that the average for the first one is going to be the same as the average for the second one. Okay, so before John Baylor was the same as after John Baylor, okay, which we're hoping that the average after John Baylor is higher, but that's what we're claiming. We're testing the claim, okay? mu1 is not equal to mu2, which is probably going to mean that mu1 is less than mu2, or after John Baylor is higher than before John Baylor, okay? Now, we already looked these up yesterday, the critical numbers for a 20% confidence interval, a 10% confidence interval. So I'm going to kind of copy these onto the back side here, and let's see. 1.363, 1.796. 1.363, 1.796. So those are both negatives. I'm just copying those from the front. These are going to be the positive 1.363 and 1.796. We're copying those. That's these cutoff marks right here that will determine whether our test statistic is in the clear or in the dark area. Okay. The other two numbers are 2.201 and 3.106. 2.201 and 3.106. I can't believe I can remember that. 3.106. Okay, so we're going to be testing those numbers according to the bell curve and our test statistic for each one of these categories. Okay, so we're going to be doing that down here. Test statistic from the front side, we're going to use that same formula that we did in 9.3, which was d bar minus mu d. Okay, we said that was 0 over the standard deviation divided by the square root of n. Okay, so what we need to do is we need to figure out what our standard deviation and our d-bar is for each one of these categories. Okay, we're just going to do math together. I'll have you do science, English, reading, but it's going to be kind of the same thing. You'll just have to compute a different test statistic. Okay, so if we go back to this front side here, I told you guys to go ahead and fill these 4 columns out and get the math. I went ahead and filled the math out because that's the one that we're going to be doing here. So I don't know, I kind of noticed that there's only 2 students that went down, and they only went down a point from before John Baylor to after John Baylor, which is kind of good. There's 1 student in here that raised it 6 points, so evidently John Baylor kind of had an effect on them, or they just really bombed the first time, I don't know. So I have the spreadsheet that I had here yesterday, and the mean and the standard deviation, I already have those formulas in here. What's going to be really nice is as I change these numbers, it's going to automatically change the mean and standard deviation for me. So that'll be really nice. I'm just going to type these in. 1, -1, 1, 2, 1, 1, 6, 4. Okay, so it's changing my mean and standard deviation already. Let's go to the, well, I'll write them down on here. 1.58 is the mean. The standard deviation is 1.98 on average. Ooh, they're really fuzzy. Okay. So let's go to the other side. So I'll just write it right here. D bar is 1.58. Let me go down. 1.58. Standard deviation is SD 1.98. Okay, and then I just need to figure out what T is. Okay, so according to my test statistic, we do D bar 1.58 minus 0 over the 1.98 and the square root of n, and n is 12 still, because we solved those 12 students, okay? So I'm going to figure out what this is, and I get a number here, okay? So I'm going to calculate. Let's get 1.58 divided by parentheses, 1.98 divided by the square root of 12. Okay, and I got 2.76. 2.76. Okay, so, all right, 2.76 is going to live, if I look at these critical numbers here, okay, 2.76 will live here in the dark region for these three categories, but then as soon as I get to a 1% confidence interval, now he is in the clear, okay? So at the 20% confidence interval, you know, he's in the dark region, but at 99% confidence interval or 1%, he is a fail to reject. Okay, so dark over here, this is going to be a reject, 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 and this one is a fail to reject because he's in the light color. Okay, so now what does this mean? Effective versus not effective. Okay, so we are rejecting this thing in these first three examples, which means we're saying that they are not equal to each other, which means that we're saying that John Baylor did have an effect, and the second time around our scores were higher than the first time, okay? So if we reject this, then we're saying that John Baylor is effective, okay? If that makes any sense at all. They're not equal to, the scores are not equal to each other. The second time around was higher than the first time around. So effective, 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 not effective, okay? So when we get up to a 99% confidence interval, now remember 99% confidence interval, the larger or the more confident you are, the larger your error is, basically. Okay, so if we have a really large error or a larger range, they're gonna let a lot more numbers in between here. Okay, so it was considered not necessarily effective at the 99% confidence interval. Okay, so that's kind of how that changes. So what I want you to do for homework, and then you'll send this in to me, is calculate your test statistic for each one of those, just like how we did up above here. You'll need to get the standard deviation and the mean from the front side, and then kind of fill these in to see, you know, was science effective? Was English considered effective? Did John Baylor do, you know, was it effective for reading? That type of thing. Okay, so it's just kind of interesting to see, you know, and I showed this to Mr. Hubble last year, and he thought it was kind of cool that, you know, this is just kind of proof that, you know, for the most part, John Baylor is actually doing its job, and the thousands of dollars that we spend on him every year is actually getting put to good use. So there is that. Do those three parts and send that to me, and then we'll move on to the next thing.